I had a member of our center say that they were interested in learning about filters because they were new and they were trying to get a new telescope set up. And so I thought it might be a good idea to very quickly go through a review of filters for people just so they know exactly how to use these things. Color filters work by absorption and transmission. They can determine which part of the spectrum we are reflecting and transmitting, and they can be used to increase contrast and to enhance the details of the moon and planets. So there are chromatic aberration filters. These are the sort of things you use to correct chromatic aberration in a refractor telescope. It reduces that purplish halo that you get because of that aberration. And these can obscure features of bright objects, especially the moon and planets. So they are useful for that. If you got a red filter, it reduces sky brightness, particularly during daylight twilight operations. It improves definition of Martian Maria and polar areas. It improves the contrast of blue clouds against the background of Jupiter and Saturn. If you've got a deep yellow, that improves resolution of the features of Venus and Jupiter, especially the polar regions, and Saturn, and it increased the contrast of polar caps, clouds, ice, and dust storms on Mars. And it enhances comet trails, if you're looking at comets. Dark green improves cloud patterns on Venus. It reduces sky brightness during daylight operations or observations of Venus. It increases contrast of ice and polar caps on Mars. It improves visibility of the Great Red Spot, if you look at Jupiter, and other features in Jupiter's atmosphere, and it enhances white clouds in polar regions on Saturn. Medium blue enhances contrast of the moon. It increases contrast of faint shading on Venus's clouds, enhances surface features, clouds, ice, and storms on Mars, enhances definition of boundaries between features and atmospheres of Jupiter and Saturn, and it improves definition of comet gas trails. If you're looking at the moon, and if you've ever tried to do that without a neutral density filter, what happens is you take your eye away from the eyepiece and you got night vision in one eye and not in the other. It's a really good idea to use a neutral filter if you're going to view something as bright as the moon. You can also use a polarizing filter, which will adjust to give you a range of transmissions between 3 and 40 degrees. You can use them for planetary observations as well, but don't ever try to use this as a solar filter. Bad idea. We'll talk a little bit more about solar filters in a moment. Then there's a whole family of narrowband filters, and these basically transmit only a narrow band of spectral lines from the spectrum, usually 22 nanometers or less. They're used normally for nebulae observation or galaxies because these objects radiate doubly ionized oxygen in the visible spectrum around 500 nanometers, and also in a hydrogen beta and alpha ranges. So the one that I use quite a bit is an ultra-high contrast, which is an all-purpose kind of filter. It's got multiple strong emission lines. It ranges from 484 to 506 nanometers. It transmits both oxygen 3 and hydrogen beta. It blocks a large fraction of light pollution, so it's helpful for that. And it brings out detail. So just to give you an example here from cloudy nights, you can see on the left is a view without the filter. On the right, you can see how the background has become darker. It makes the object pop out. That's basically the thing that'll do for you. This is, of course, astrophotography, but it'll do the same thing if you're just viewing at the eyepiece. It makes the background appear darker so the object stands out. Then there are specific emission line filters: hydrogen alpha, hydrogen beta, oxygen 3, sulfur 2, and you can get all 4 of these and use them to enhance your viewing. I have an oxygen 3 that I use all the time. Here is an example of what happens when you use an oxygen 3 with no filter on the left. And with the filter, you see, again, the background gets darker, the object pops out, makes it easier to see. That's why I use it to view things like the Veil Nebula. This is an example of a hydrogen alpha filter for astrophotography. You can see how it enhances certain aspects of the Dumbbell Nebula here. And here's a interesting slide from Agena Astro Products, who make filters, and you can see they've taken a hydrogen alpha and oxygen 3, a silicon 2, and then they've combined them all to make a photo. There's also broadband light production, pollution reduction filters, LPRs, and these more recently came out because of people trying to deal with the misuse of artificial light at night. Again, you can see on the left without and with Celestron LPR filter, on the right, it again will knock out some of that background stuff and make it easier for you to see these things in the sky. Now, we're going to do solar observing, and we do a lot in this club. Don't ever use an eyepiece solar filter. I got one of these with my first telescope when I was a kid. It came with one of these, and I mean, I had no idea that they were so dangerous. Basically, all the light goes to the telescope, is focused on this thing, which heats up and eventually can crack. And if you're looking through it when it cracks, you're going to damage your eyes. You need to use proper filters. This is somebody that was at whatever events viewing a solar eclipse and they're using a welder's mask. That works. But a white light filter, at the very least, which you put at the front end of the telescope to keep most of the light from getting in there in the first place. We use that with a neutral density filter. You see one of our former members, Scott, here, using them on binoculars. There's also the Herschel Wedge, which is invented by William Herschel in the 1700s. This is a prism that redirects 95% of the light into that heat sink block, which is that bright spot at the end of the prism there, and the rest of it goes through your eyepiece, and you'll use a neutral density filter to adjust. They're good, but they're expensive. I know Michael Bradley uses one a lot. And the other is the hydrogen alpha, and as you can see, that's my Coronado there that we were using when we were viewing the eclipse in Oregon a few years ago. That's basically an Edelon filter, which is a couple of mirrored pieces of glass that only let certain frequencies of light go through, all the others cancel out. There's Danny's Lunt pressurized stacked hydrogen alpha. So that's the kind of filter you're going to need if you're going to look at stuff when you're viewing the sky during the daytime. So if you have any other questions about filters, don't hesitate to give us a call. We have some up at the observatory if you need to borrow them and try them out. And thanks for taking the time.